Hi guys, welcome back to our YouTube channel. In today's video, we'll be looking at another question which is from courseheroes.com. So in this question, we asked to use the Lagrange multipliers to find the points on the plane x minus 2y plus 3z is equals to 6, that is closest to the point 0, 1, and 5. So without wasting much of our time, let's dive into action. So the first step we'll be applying, step 1, is to minimize the square of the distance from our general point xyz then to the point given, which is 0, 1, 5. So to do this, that will lead to the creation of our function f of xyz. So this will be f of xyz will now be x, that is our general point x, minus the point given is 0, then square, plus y minus the point given, which is 1 square, then z minus 5 square. So that will give us our f function. So now after that, then we identify our constraint. Our constraint, which is g of xyz, is x minus 2y plus 3z minus 6, which is actually our given function. So this is our constraint function here. So now this leads us to step 2. Now we have identified our f and our g of xyz. So the next thing is to apply the Lagrange equation. So let's apply the Lagrange equation in step 2. So Lagrange equation is the gradient of f is equals to lambda times the gradient of g. So that is it. And what is the gradient of f? The gradient of f is just the partial differentiation of f with respect to x, with respect to y, and with respect to z. So same with g as well, partial differentiation of g with respect to x, y, and z. So that was the gradient of f. So the gradient of f will give us, after partial differentiation, 2x, 2y minus y, and 2z minus 5. So same thing as gradient of g, which is 1, minus 2, and 3. So we have gotten our gradient of f and our gradient of g. So the next thing is to insert this one by one, individually, 10 by 10, into the Lagrange equation. So that will be for x now. For the first one, for x, that will be 2x is equals to lambda times 1. So then we will be able to get the value for our x, that is, we isolate our x, which gives us equation 1. So continue this process until we are done with z. So we need to isolate x, y, and z so that we can insert them into the constraint function. That is just what we want to do. So now we have gotten for x, which is lambda over 2. So that is equation 1. Then for next one, for y, so y will be 1 minus lambda, which is equation 2. Then from z now, equating time by time again as well, 2z minus 5 equals to 3 lambda. So lambda will give us 5 plus 3 lambda over 2. So which is our equation 3. So that's being said, equation, we have gotten x, y, and z. So the next step, which is step 3, is to substitute this x, y, and z into the constraint g, x, y, and z, so we can solve for the unknown. So now let's apply that. So to solve for the unknown, then this is our constraint function, which is x minus 2y plus 3z is equals to 6. So now let's insert this into the constraint. So that will be lambda over 2 minus 2, 1 minus lambda plus 3 times, that is our z, equals to 6. Now let's try to find our lambda now. So let's multiply both side by 2 to eliminate the fraction part. So that will give us, after multiplying both side by 2, we have lambda minus 4, 1 minus lambda plus 6, 2 bracket 5 plus lambda over 2. So this will give us lambda minus 4 plus 4 lambda plus 30 plus 9 lambda is equals to 12. So let's try to collect lag terms and then we solve for lambda finally. So that will give us 14 lambda is plus 26 is equals to 12. Then lambda will give us minus 1 after dividing both sides by 14 by 14. So that's it. Now that we have gotten for lambda, which is minus 1, so we'll go back to our constraint again. Sorry, no, we are done with the constraint. We'll go back to our equation 1, 2, 3. So we can plug in the value of lambda in each respective variable. So don't forget our equation 1, our x was lambda over 2. So all we just need to replace wherever lambda is with minus 1. So that is step 4. Plug in lambda is equal to minus 1 into equation 1, 2, and 3. So the first one, x lambda over 2, which is minus 1 over 2. So that is our x. Then for our y, which is 1 minus lambda, it becomes y is equals to 2. Then for our z, 5 plus 3 lambda over 2 is then 7 over 2 after inserting the lambda. So we have just gotten our x, y, and z. So which is the closest point to the point 0, 1, 5 that we are asked to find. So hence, the closest point on the plane to 0, 1, 5 is, so we just need to bring our new value for x, y, and z. So that will be our closest points, which is then minus 1 over 2, 2, and 7 over 2. So that's it. Very easy and straightforward. So thank you very much. So like and subscribe.